In this exercise, we're told that a student goes to the library, and we're asked to let event B equal the student checks out a book, and event D equal the student checks out a DVD. Suppose that the probability of B, so the probability the student checks out a book, is 0.40. The probability of D, the probability that a student checks out a DVD, is 0.3. And the probability of both A and D, so checking out a book and a DVD, is 0.20. So first we're asked to find the conditional probability, the probability of B given D. So probability of checking out a book given that they've checked out a DVD equals the probability of both B and D, so the probability of checking out a book and a DVD divided by the probability of checking out a DVD. So we're given the probability of A and D as 0.2. And then the probability of D is 0.3. So that equals 2/3, or approximately 0.67, or 67%. Now similarly, now we're asked to find the probability of checking out a DVD given that the student checked out a book. So the probability of D given B equals, again, probability of B and D, or you could say probability of D and B, but that's going to be the same thing. So the probability of B and D, but now we're dividing by the probability of checking out a book. So that equals 0.2 divided by 0.4, which equals 2/4, which equals 1/2, or 0.5, or 50%. So now we're asked, are B and D independent? Are the events that a student checks, this particular student checks out a book and checks out a DVD, are those independent events? Now there are several ways, if you remember, that we could go about checking if they're independent. We really know that they're already not independent because the probability of one given the other is not the same. Going one direction, it's 67%. Going the other direction, it's 50%. But we also, the easiest way to remember this is, does the probability of B and D equal the probability of B times the probability of D? So does the probability of both of them equal the product of their individual probabilities? Well, if we look at probability of B, probability of checking out a book times the probability of checking out a DVD, we have 0.4, which was given, times 0.3, which was given, which equals 0.12. But we're also given that the probability of A and D, or sorry, probability of B and D, used to looking at formulas, probability of B and D, the probability of checking out a book and checking out a DVD, equals, we're given that that is 0.2. So since these are not equal, we know that the answer to, are B and D independent? The answer is no, and here's why. Now, are they mutually exclusive? Well, we're given that the probability of B and D, probability of checking out a book and a DVD, is 0.2. That's not 0. So they are not mutually exclusive. The answer to that is also no.